So when we talk about the logarithm function, you need to keep in mind logarithm is the inverse of exponential. The exponential function that we did over here, the properties are going to be very similar because they're the very similar type of graph. So the first graph over here. So anything that it looks like, it's going to go very similar as we didn't draw the graph over here, but it's going to be very similar as the exponential graph that we already dealt with. So if you look at this one, let's look at the graph and turn it on. All right. So if you look at the graph for y equal to log x, close the parentheses, and you graph this one, it's going to look like this. Let me make it a little bigger. Okay. So that's the graph that we can see. We see that there is an x-intercept. There will be no y-intercept. X equal to 0 is going to be your vertical asymptote. There is no horizontal asymptote. It's going to be a vertical asymptote. All right. So it's not y equal to anything, it's x equal to, because it's going to be a vertical asymptote, not a horizontal. So keep those small things in mind while you are working. If you are trying to find the value, the actual value for any, so we had all these points, all the regular universal point that we always use. And if we try to find the values over here, so for log -2, if you hit enter, it's going to give you an undefined value. If we try for log -1, again that's undefined. So if you put log 0, that's also undefined. If you plug in log 1, that's giving me my first defined value. So at log 1, we are having 0. So at 1, my value is going to be 0. That's my first point. For log 2, I have 0.3. It's a little less than 0.5. So it's going to be somewhere over here. I want to see how the graph goes, how the graph looks like, how it increases. So I just want to plug in few more values just to see it. You don't have to do it if you know that, okay, this is how it's going to look like. I just want to see how it looks like. So here, for log, say for log 3, I put it through, so log 3, if you hit enter, it's 0.4. So it's increasing a little bit, so going up a little bit every time. So for 3, I'm going to have a 0.4. If I plug in 4 over here, what's the value for log 4? Somebody give me? 0.60. So it's increasing a little bit. How about over here? So x value is 0.5. 0.5. Give me the value for log 0.5. Put it in your calculator, all of you. Put 0.5. The x value is 0.5. Log 0.5. It's giving me negative 0.3. So we are getting negative values. So it's going to be negative 0.3 over here somewhere. Let's see negative, let's put 0.75. We're going closer. Okay. So if you plug in log 0.75, hit enter, it's going to be negative 1.2. So it's going to, for 75, it's going to be negative 1.2 over here. So now, sorry, over here. So here it's going to be negative 0.3. So now you see that when we plug in any value closer to 0, it's giving me all the negative values over here. And when we are putting any value which is bigger than 1, 2, 3, those 3, 4, when x values are going more farther from 0 value, it's giving me all the positive values over here. So the graph is going to look like this way. Make sense? We good on the graphing? Okay. Now, we're going to talk about the properties. Remember, what is my vertical asymptote over here? What is my vertical asymptote? X equal to 0. That's going to be my vertical asymptote. What does it mean by x equal to 0 is the vertical asymptote? What is the meaning of it? The line will never cross. It's going to keep going closer and closer and closer, but it will never touch or cross that line. Okay, let's look at the properties now. So tell me, what will be the domain on this one? 0 to infinity. We cannot take anything below 0 because anything below 0 is giving me all the undefined values. At 0, it's undefined also. So the domain is 0 to infinity. Is it open or closed? Is it open or closed? Why open? Why not closed? Because if you take the 0, it's giving me undefined, so I cannot include the 0. It's undefined. Thank you. Range. What will be the range? Negative infinity up to a positive infinity. Thank you. Increasing. Is it graph increasing anywhere? Where is it increasing? Huh? For which x values the graph is increasing? Always increasing, decreasing is for from which interval? 0 to infinity, it's increasing. Thank you. Decreasing, is it decreasing anywhere? No, it's not, because whenever we are putting all these values, it's according to the values, you're going closer and closer and closer, but it's not decreasing anywhere. So that's not an option here. X-intercept, do we have any x-intercept? What is the x-intercept? 1, 0. It's a coordinate. Y-intercept, do we have any y-intercept? None. Vertex, do we have any vertex? It's increasing, so there is no vertex. Symmetric, is the graph symmetric? No. Okay. Roots, do we have any? X equal to 1. Thank you. Asymptote. Do we have any asymptote? We have a vertical asymptote. Remember, every time we considered horizontal asymptotes. This one is a vertical asymptote. So that's different. And it's x equal to 0. Maximum. Do we have any maximum point? Nope. Minimum? Axis of symmetry. Axis of symmetry. There is none. It's not symmetric, so we cannot have any axis of symmetry. Question? Any question? We don't need the Chromebooks, Vidi. Thank you. Let's look at the transformation now. The transformation rules are same. It doesn't change anything on this one. It's the very similar things that we did so far. All the transformation rules are exactly same. So I didn't include that paper anymore with it. So if you look at this one over here, we're just going to write the domain, range, and the transformation. Okay, let's look at the graph now. So over here, remember we had these points over here, and the graph started from 0, 1. So that was my starting point, and I had a vertical asymptote at x equal to 0. So over here, what is my transformation? That's my first question. So it's going to go left 2. Everything will stay the same. You can make the table, of course. There is no wrong with making the table. I prefer making the table. But on this one, just only one transformation, so I'm not making it. I'm just shifting. The original was starting over here. I'm just shifting my graph 2 units to the left. So 2 units to the left, that's my starting point. And then, since I had x equal to 0, that was my vertical asymptote, I'm going to shift it 2 units to the left. So my vertical asymptote is going to be over here. I just did it because there is only one transformation. We can make a table also. There is no problem in making the table. So that's my graph. Question? Any question on this one? Don't get used to with the big calculators, please, because you are not going to have it from tomorrow. It's just for you to look at the graphs for today. So get used to with no calculator portion. All right, look at this one. Tell me, what would be the domain for this one? What would be the domain of this graph? -2 up to positive infinity. Uh-oh, sorry. What will be the range? Question. You can even check it with your calculator. That will show you. That's why I gave you those calculators. So first do it by yourself, then check your work with the calculator. That's what checking. Question. If there is no question, do the other 2 problems. If I explain this one, the y equal to log x, it's the base 10. So y equal to log 10 base x minus 1. Ln x is log 10 base x. You need to know about this property because we're going to use it tomorrow. We need this property. The ln, the natural log x is actually technically log 10 base x. You can put it in your calculator. The log is going to be, I forgot, is it the alpha window? And then number 5, you can plug in the base over here. So it's going to bring you all the base. So you can type in your base. So alpha window 5. And this one over here, I can plug in. So I have log, then I have base 3. And then it's going to be x plus 2. X plus 2. If you graph it, it's going to show you the graph. This is the graph. No. Sorry. Clear. Alpha window 5, 3, and then x plus 1. 2. Here. It's going to go down though. Okay? All right. All right, go ahead, do the other 2 problems. I'm giving you 4 minutes to do it, and 3 minutes would be more than enough. And once you are done, please raise your hand so I can have a look at it. Give me a sec, sweetheart. All right, go to your practice packet. There are very few problems on this one. So we're going to talk, you are going to work on the transformations over here, and then only 4 graphs. So you're going to do it now. Bring it to me so you can check your work and I can stamp it today. You have, 20 minutes to do it. It's a lot of time. Go ahead, get started. Any question on this one so far? Yes.